First question. Evaluate the given expression and express the result using the usual format for writing numbers instead of scientific notation. What do we have here? First of all, P, it's meaning combination. Combination of element of 2 that you can choose out of 49 total. So for that type of problem, I will place here also, but I have placed the link to the online calculator under, I believe, chapter 3.4. If not, then check. It's going to be either 2, 3, or 4. Link to the calculator when you are going to plug numbers. And you should get, let's say, provide the permutation of 2 out of 52, it's going to be 2,652. Where from it's coming? So all kinds of combination of 2 from 50. So you take first one, let's say, and then next 49 combination, and then you take second one and next 49 combination. Okay, and that's where from it's coming this large number. Okay, next one. Decide if the situation involves permutation, combination, or neither. Explain your reasoning. The number of ways a 4-member committee can be chosen from 11 people. Does the situation involve permutation, combination, or neither? Okay, I am wondering if it does matter how many, who you vote in the committee, you choose for committee first one or last one, or the second one. At this point, I believe order doesn't matter. At this point, it's gonna be combination. So let me see. It's gonna be C. Combination. Okay, next one. Determine whether the following problem involves permutation or combination and explain your answer. So how many different the 7-letter passwords can be formed from letters L, M, N, O, P, Q, and R if no repetition of letters is allowed? Okay, this problem is involved in permutation. Why? Because the order in which the letters are selected, it does matter. Look at that. L, M, N, O, P, Q, R. They are in order, right? So let me see, where is the answer? The problem involves permutation. Okay, this is gonna be, looks like B, because the order in which the letters are selected does matter. Yes, it's gonna be B. This is number 3, right? This was number 2. Okay. Now, in your case, it's not necessarily has to be a precise answer. You might have a different either permutation or combination. So you have just to read it and just listen my explanation why I choose the way I choose, and that will help you to figure it out, your answer. Okay, a class has 33 students. In how many ways can 4 students from a group form a group for an activity? Assume the order of the student is not important. Let me check. Of the student is not important, that's right. Okay. So if order is not important, we can use, this is number question, right? So if the order is not important, then we can use combination. So you know different combination versus permutation. You calculate based on if order is important, you choose permutation. Order is not important, you use combination. Since the order is not important, so we choose combination. 4 students. See, we have 4 students, and we choose out of 33. Okay, a certain lottery has 31 numbers. In how many different ways can 5 of the numbers be selected? Assume that order is not important. So if the order is not important, then we are going to choose the combination, right? For number 5, we are going to use combination. In a different way, 5 of them, 5 out of 31. So if you plug in the calculator, you will get 169,911 combination. Next, according to a study, this is going number 6. According to a study, 81% of the K-12 schools or districts in a country, use digital content such as ebook, audiobook, what else is in there, and digital books. Of the 81%, 8 out of 20 use digital content as a part of their curriculum. Find the probability that randomly selected school or district uses digital content and uses as a part of their curriculum. Okay, so the key part here, out of 81%, and this 81% study of K-12 schools, out of 81%, 8 out of 20 use digital content, which is very nice. The probability that randomly selected school or district uses digital content and uses is as a part of this curriculum is, let me see what we got here, 0.324. Let me explain to you how we got 0.324. First of all, we have 81% and we have 8 out of 20. So 81%, number 6, it's going to be 0.81, right? And 8 out of 10, it's times 8 out of 10. And you should get this answer here, 324. Okay, why we multiply? Because we have 81% and then we take out of 81% in this, and 85% and portion of 85. So we take 81% and multiply by percentage of the portion. Okay, next moving to question number 7. A doctor gives a patient a 70% chance of surviving bypass surgery after heart attack. If the patient survives the surgery, then the patient has 35% chance that the heart damage will heal. Find the probability that patient survives the surgery and heart damage heals. So we have 35% chance and 70% of surviving bypass surgery. Okay, so what we are going to do, and I'm calculating 0.7, we need to multiply by 0.35, and we are getting precisely 0.245. So number 7, 70% is 0.7, multiply 0.35, because again 0.35 is a portion of from this 70%, right? If the patient survives, see, then you take calculate 35% of this 70%, and you will get 0.245. 5. Okay, question number 8. Let's go. Question number 8. What do we have? The responses of 1191 adults. Okay. The responses of 1191 adults in a certain region to survey question about the story of Britain's vote to leave the European Union are shown in the accompanying Pareto chart. Okay, find the probability of each event listed in parts A through D. Okay, first one, the probability, let me move this one. Let me see. There we go. What do we have? So question number 1, find the probability of each event. So the probability, we randomly select an adult who thinks the story is somewhat important. So somewhat important, here is the key. How many we have? Somewhat important is C. Where is my C? C is, I have 346. Well, I can't write down here, but it's the highest, the column, 346. And total, our total is, how much was our total? 1091. So you take 346 and divide by our total, 1191. Next, randomly selecting an adult, who think the story is somewhat important. No, this is, we did A, moving to B. Who thinks that story is not at all important. Which one is it? Not at all. It's E. The value of the key E column is 183. So we are taking this 183 and we divide to our total, and you should get 154. Let me just double checking. You can take 183 and divide by 1191, right? And you are getting 0.1536, since it's asking to round till 3 decimals, getting 154, 0.154. Okay, question number C. Randomly selecting an adult who thinks the story is not too important or not at all important. Let's go there. It's not important, or not too important, or not at all important. So D is, we have 220, and E is D and E. So 220 plus 183, right? 220 plus 183. We are going to get how much? 403. And 403 we divide by 1191, and we are going to get 0.338. That's answer for C. Next one, moving to D, last one, randomly selecting adult who thinks that the story is extremely important or very important. Okay, extremely important is A, and very important is B. So A and B, which is going to be 240, right? Plus A is 166, and we are getting 406, and divided by 1191. And the answer is 0.341, and that answer is D. Okay, So we solved every single one of them. Question number 9. So let's see what we have with question number 9. The accompanying table shows the numbers of male and female students in a certain region who received bachelor degree in a certain field in a recent year. A student is selected at random. Find the probability of each event listed in part A through C below. Okay, this is the table we are going to use. First of all, we need to find, let me see. A, we need to find that the student is male or received degree in the field. So the student is male. We have 778,297 over 1,766,477. Actually, since it's going to be common denominator, I can move it. So it is male or received a degree in the field. So degree in the field is, let me see, degree in the field 290 total. It's 290,739. Okay, and look what's happening. 156,387 is we are getting intersection, which is we are getting male, that is it's a male and in the degree in field. So this 156,387 is duplicated, so therefore we need to subtract, so to avoid duplication, because male is going horizontally, degree in field vertically, so intersection is going to be the one that is going to be repeating and in the row and in the column. Therefore I need to subtract to eliminate duplication, and it's going to be minus 156,387, and all this divide by the overall total. Okay, and that will be the answer for A. Next one, moving to next one. What is the next one? The student is, it's B. The student is female or received degree outside of field. So we have here female and degree outside of field. So female is gonna be 988 total, 180, and then outside of degree, outside of field, it's 1,475,738. And because there is also intersection, female goes horizontally and degree outside, it's coming in columns. So intersection 853,828 minus 853,828, and all these we are dividing by grand total, and this is going to be 1,766,471. Okay, next question, question C. The student is not female or received degree outside of field. So not female, we have only one choice left, is male, which is 778,297, and plus outside degree, it's going to be 1,475,738, and minus intersection between male and outside degree, it's going to be minus 621,910, and all this we are dividing by grand total, which is 1,766,477. Okay, and the last one, and you can see the answers here. So if you want to practice on this one, as I explained, get the number first and then move to your problem. Here this you have solution, and I'm just telling you how to solve. And okay, that's it. There is no other D anymore here. All right, and next question number 10. All right, what do we have here? The percent of college students marijuana use for sample 94,655 students is shown in the accompanying pie chart. Find the probability of each event. Okay, first thing we need to find randomly selected students who never used marijuana, and it's where is it? Never used marijuana. That's a blue one. It's 53.6 degrees. Next, randomly selecting a student who used marijuana. Let me see, what do we have here? Who used marijuana? We have used, so all three, right? Red, green, and blue. So it's 26%. We have 26% plus 10%. It doesn't say how many days, it's just asking used, period. 10% plus 7% and plus 3.4%. Okay, let's go. 26 plus 10 is 26, right? 26 plus 7, 33. And 33 plus 3.4, it's gonna be 36.4. There is 46. What am I missing here? Randomly select a student who used marijuana. So 26, 10, 7, 3.4. Okay, 36. Okay, 26 plus 10, 36. The 36 plus 7, 43. And 46.4. Okay, we got it. That's a B, right? All right. Next one. What do we have with next one? Randomly selecting a student. Let me read this. That's C. Randomly selecting a student who used marijuana between 1 and 29 of these last 30 days. 1 through 29. So we have 1 through 9 and then 10 through 29. So it's going to be 10% plus 7%, right? From 1 through 29, it's going to be 17%. Okay? And the number D, randomly selecting student who used marijuana at least one of the last 30 days. At least one of the last 30 days. So we have used all 30 days, which is 3.4. So we are going to get, how many we had? 10 plus 7 plus 3.4 and plus 26. So we had 46.4% all these used days, and at least we need to find at least the last 30 days. Therefore, what we are going to do, we need to find the one that used but not in the last 30 days, which is 26%. It's red color, 26%. So from 46% we had 46% we have for all these used cases, which is a red color, green color, yellow, and purple. So this 46.4 minus the one that was used and not, at least not last 30 days, which is going to be 26%. And the answer we get 20.4%. Okay, and the last question. A study was conducted of the trend in the design of social robots. In a random sample of 103 social robots, 64 were built with legs only, 17 were built with wheels only, 7 were built with both legs and wheels, and 15 were built with neither legs nor wheels. Use the rule of complements to find the probability that random selected social robot is designed with legs or without wheels. Okay, since we don't have without wheels case, we need to find the case when we have with wheels. And that is how many we have? 17 were built with wheels only. So the probability of the randomly picked robot is gonna be with wheels only. We take this 17 and divide by 103 and you get 0.165. Therefore, then since we are going to use with the rule of complement, 1 minus 0.165, it's going to be our robot that is designed with legs or without wheel. Okay, I'm done solving, so I wish you good luck, and you have any questions, please contact me.